Hi, I'm Darshana Sharma, and here's my review on Lab 1 charge tape. So the purpose of this lab was to determine how much excess charge is on one piece of clear tape and to understand the ideas of charge, design thoughtful experiments with household objects, make estimates and simplify assumptions based on what we learn in lectures, and understand excess charge on ordinary objects. And a preview of my results that I get at the end are that the pieces of tape repelled each other due to both having positive charges. The electric charge on one tape is 3.5 times 10 to the negative 8 coulombs, and the tape is deficient with 2.1 times 10 to the positive 11 electrons. The formulas we use in this lab are Coulomb's law to calculate electric force. And in here, because it's a point charge, Q, there's only one Q value in the numerator, so it's going to be Q squared. And D is the distance between the charges. Additionally, we use F equals ma and F equals mg to calculate the forces acting upon each of the pieces of tape in the experiment. And the assumptions of this lab are that the center of tape is treated as a point charge, and both tapes have the same amount of charge. So for model one, the system is tape B and the surrounding is everything else, meaning hand, the table that it is sticking upon, and tape A. So every other charge that is acting upon it. And the initial conditions are that the length of the tape is 0.2 meters, the width of the tape is 0.02 meters, and the mass of the tape is 2 times 10 to the negative 4 kilograms. So the observation seen in this lab is that there's a traction between the U-tape in my hand, as you can see in this photo above. There's a traction between the U-tape and the table, which is a neutral object. There's a traction between the U-tape and the charged pen, which has a negative charge as we rubbed it on our clothes and in our hair. And there's repulsion between the U-tape and the second tape, as seen in this video below. So from these attractive forces and understanding the repulsion between the U-tape and the second tape that was charged in the same manner, I can infer that the U-tape has a positive charge because of these interactions. For Model 2, the system is tape B, which is a suspended U-tape hanging between the two objects, and the surrounding is tape A, which is a U-tape being held up and put into contact with the tape B. And the initial conditions are the same as observed Model 1. So from this experiment, I can observe a repulsion between the suspended tape hanging between two items, which is tape B and tape A, resulting in tape B moving upwards from hanging with slack between the laptops to being bent upward by the electric force provided by tape A. And the separation distance observed by both these tapes is 0.075 meters. So here are two free body diagrams illustrating these force interactions. As you can see in the first free body diagram, which illustrates tape B, the electric force from tape A is an upward acting force, whereas the force of gravity is a downward acting force. And the held tape, which is tape A, has the force from tape B, the electric force acting downward upon it, and the force of holding the tape is an upward acting force. So from this free body diagram, we can see that the forces cancel out and the net force in this system is 0. So for data calculation, all my known values are values that I stated prior this presentation. And to calculate the electric charge, we have to first calculate the surface area in order to get the number of atoms in the system. And from that, we use the formula previously mentioned, F equals mg, to calculate the weight of the tape. So now we know the weight of the tape is 0.00196 newtons in the y direction. And we know this because the free body diagram says that the force of gravity is equal to the electric force. So we know that this is a force acting in the y direction and that the forces are 0 in the x and z direction. We use these values to rearrange Coulomb's law to get Q equals square root of force times r squared over k to get positive 3.5 times 10 to the negative 8. And we use this value to calculate the electron deficiency in the entire system, which is 2.1 times 10 to the positive 11. And we use that deficient electron number and divide it by the total electron to get the ratio of electrons, which is 5.3 times 10 to the negative 6 electrons. Here's a computational model describing everything, all the calculations I just stated. So first I illustrated my content and then my constant, and then I calculated the gravitational electric forces in order to get to understand Q and the charge. So then I use those values to calculate the charge, and then I use the charge to calculate the deficient electrons. And from there, I can calculate the total number of atoms and then create a ratio of deficient electrons to atoms to understand how the charge on the tape. And here is a model of my forces. So as you can see here, the arrows are the same length and they cancel out, indicating that there is no net force in the system. So from my results, I understand that the tape is positively charged and there's an electron deficiency. As the potential sources of error are human errors from measuring the tape incorrectly and measuring the distance between tape A and tape B incorrectly, and there could be calculation errors when rounding. So question one states that if electrons had positive charges and protons had negative charges, what would happen? So if the charges were swapped, the electric field would point towards the tape instead of away. However, the tape behavior would still be the same, as both pieces of tape would now both be negatively charged and would still both repel each other, and a pen would become positively charged, but it would still be attracted to the tape. Ergo, the tape behavior and force behavior would still be the same. Additionally, it's important to handle the charge tape as little as possible because the electrons can easily be transferred between objects in contact, and this will change the overall positive or negative charge of the tape as electrons are being transferred out, and it would change its properties. Thank you so much.